So at this point, what we want to do is describe the formulas to convert between polar and rectangular coordinates in both directions. So first, let's look at polar to rectangular. Let's suppose that I'm given a polar point of the form r theta, and I want to know what its rectangular equivalent is. So the way you do that is think about this point as being a point on a triangle. So let's see, why is that coming out so thin? There we go. Think of it as being a point on this triangle. So if I draw a triangle like this, what we can see is that I'm looking to write this point in the form x comma y, where this would be the distance y and this would be the distance x leading to the point xy. So what we can see is that y over r is equal to sine of theta, and x over r is equal to cosine theta, just based on what we know about trigonometry, about sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and we can see that the legs marked y and x are the opposite and adjacent sides to the angle theta. So multiplying both of these equations by r, we see that the way that you would convert is you would write y equals r sine theta and x equals r cosine theta. This is going to be important because it means that we can always, given any r and theta, we can always find the x and y coordinates in this way. Uh, so anyway, this is the way that you would convert from polar to rectangular. So now let's look at rectangular to polar. Let's suppose that I'm given the point xy, and I want to know how to convert it into polar coordinates. So once again, we're going to draw in this triangle like that. And we can see is that if this is of length y and this is of length x, we can see that the dotted line here is going to be of length square root of x squared plus y squared. In other words, just by the Pythagorean theorem, we're just looking at you can consider it the distance formula even, which is just an application of the Pythagorean theorem. We're looking for the distance between the point at the origin and the point xy, which is going to be square root of x squared plus y squared. So that gives us r equals the square root of x squared plus y squared. Now as for theta, what we know about theta is that we know that tan theta is going to equal y over x. Again, because tan is opposite over adjacent, and we can easily see that for this angle theta, the opposite side is y, and the adjacent side is x. So that tells us the relationship between theta and the given y and x. The thing is that it might be tempting to write here that theta equals arctan of y over x. The problem is, recall that the arctan function only gives you an angle in the range negative pi over 2 to pi over 2, exclusive of the endpoints. So it's only capable of giving us an angle that is in that range. It can't even give us the endpoints, but it says nothing about the left side of the plane. So the rule that we actually are going to need is a little bit more complicated. I'm going to write it here. It's going to be theta, I'll write it in purple. Theta equals, it's going to equal arctangent of y over x as long as x is greater than 0. It's going to equal arctangent of y over x plus pi if x is less than 0. It's going to equal pi over 2 if x equals 0 and y is positive, and it's going to equal negative pi over 2 if, actually I think we do it this way, I think we use this angle, 3 pi over 2. It's the same angle, whether I call it negative pi over 2 or 3 pi over 2, it's the same position on the unit circle, if x is equal to 0 and y is less than 0. So just to come back up here. So the idea is that if I have this point here, xy, the tangent of that angle is y over x. But if I were to come down here to this point, which would be negative x, negative y, since the ratio of the y position over the x position is going to give us the tangent of the angle, negative y over negative x is the exact same value as y over x. So what I have to do is I have to let the arctangent function give me a point on this side of the plane, and then I add half a circle. I had half a circle to get here. But in order to know that I have to do that, I have to already know that I'm looking for something on the left side of the plane, something where I'm in the negative x region, where x is less than 0. And then, of course, if x equals 0, that means that I'm somewhere on the y-axis. So if y is positive, that means I'm up here, and we say the angle is pi over 2. If y is negative, then I'm down here, and we say the angle is 3 pi over 2. So, so this is actually the rule that you need to convert, that you need to find theta given x and y. It's a little complicated because it has four separate cases, but hopefully I've explained what those cases all mean. So this is the rule for rectangular to polar, and this is the rule for polar to rectangular. Okay, so let's do a couple of examples where we convert points back and forth between rectangular and polar. So first, let's convert 3 comma 5 pi over 6 to rectangular coordinates. So we're given a polar point, we want to convert it to rectangular coordinates. Let me just put up here the conversion formula. We know that the rectangular to polar conversion formula is x equals r cosine theta and y equals r sine theta, like that. So it becomes fairly straightforward. We can say is that x is going to equal, let's remind you how to interpret this, that's r and that's theta, so x is going to equal 3 times the cosine of 5 pi over 6, and I don't know why I wrote that in red, but I'll just leave it. Y equals 3 times sine of 5 pi over 6. So this is going to equal 3 times cosine of 5 pi over 6 is negative root 3 over 2. And sine of 5 pi over 6 is 1 half. So this is going to equal negative 3 root 3 over 2, and this is going to equal 3 halves. So the answer is negative 3 root 3 over 2 and 3 halves. And we can kind of see where this would be if we graphed it. We know that if we go to 5 pi over 6, we're looking at an angle that's roughly like in that direction, and we're going three units away from the origin. Here what we're looking at is 3 root 3 over 2, or rather negative 3 root 3 over 2, so that's going to be 3 times root 3 divided by 2. That takes us to an x value of about negative 2.55, so I'll just put that in there. There's 3, so I'm looking at an x value that's roughly there, and 3 halves upward, so that's going to be 1.5. So I'm looking at, yeah, that's about where the point comes out to. I'm looking at about this point. So this is the point, negative 3 root 3 over 2, 3 halves, which can also be described as 3 comma 5 pi over 6. Okay, so that's the answer there.